Welcome to Superheroes of Science. I'm Stephen.
And I'm Sarah. We co-host Science from the Experts. Our guests are professionals doing cutting-edge science right now.
They're experts in their field discussing what they know best. So listen up and learn real science from real people.
Subscribe now and stay informed of our latest episodes and show your support.
My name is Ken Jucks. I am a program scientist at NASA headquarters. So all the scientists you see here all pay attention to me because I equal money.
Well, money does make the world go around.
Yes, that's right.
So it's being able to fund the research that they're wanting to do is obviously an important thing to them.
Yeah.
But you're as what was the title?
Program scientist.
Yeah, program scientist. I wanted to say director, but it kind of works the same though.
In some ways.
As a program scientist, why do you decide that some programs are more important, and you decide how important they are by the money you're giving them or not?
Yeah.
And so how do you decide and weigh programs?
So these are done by various approaches. Some of the field campaigns kind of bubble up from the research community.
Okay.
And then people like me decide when we can appropriately find the money to make a field campaign like this happen, and if there's an appropriate idea from the community that has bubbled up at the time when we think we can organize the money together, then we will start to push forward with it. This particular campaign was actually funded through a different route.
Oh.
So it was funded through a larger solicitation that NASA does about every 4 or 5 years called the Earth Venture Suborbital Program. This program was recommended to NASA to do under the initial decadal survey for prioritization of science going forward for NASA to do. This was from the first one that was put out about 15 years ago.
Oh, wow.
And it called for doing field campaigns where you need more longer term sustained observations to approach particular science questions. This one was selected out of the third such solicitation that we had. We selected 5 proposals to fund out of the various proposals that we received, and those all go through peer review. And we go through and they are across the earth science discipline, and we go and review each one and get an assessment, and then we make recommendations as to which ones get selected.
Okay. So what does NASA want out of this? I mean, it's your money, and so what are you giving these people money for? What is your purpose, I guess?
So we give them money to go and answer important science questions. They put together important science questions in their proposal, and we agreed it was an important science question to go after, and we agreed that they had a solid approach to go and address them. That's why it reviewed well, so that's why we selected it.
Well, that makes sense.
Yeah, it does.
But when I think of NASA, I just think of astronauts.
That's what some people think about us.
And so apparently you're a lot larger than that, and there's a lot more priorities than just like space travel.
Right. So NASA is broken up into a number of different directorates that we have. The largest directorate is the Human Exploration Directorate, where the astronauts, the International Space Station, things like that are all operated under that directorate. This is all funded out of a directorate called the Science Mission Directorate. NASA has a fairly large Science Mission Directorate to go and answer fundamental science questions that are important for society. So that's where this comes from, and that's actually a fairly significant portion of NASA's budget. So, and we are funding this. We have the Science Mission Directorate is basically broken down into 4 main divisions within the Science Mission Directorate. There's Earth Science, where we are located. There's the Astrophysics Division. There's the Planetary Science Division. Then there's the Heliophysics Division. And each one has its own director and subdirectors and
So how many different projects are you having to look over at once?
Myself, depends on how you define a project. But at any point in time of late, it's been about 8 or 9.
Okay.
It's a lot.
Well, that's what I think, because this is huge.
That's what I personally overlook.
Yeah.
I have a number of colleagues, and many of them look over the same number of types of projects. So we have a lot of things going on.
Whoa, I'd say
Wow.
so.
Yeah.
I mean, that's because this one project is huge.
Compared to some of my projects, it's nothing. The satellite projects are much bigger and much more complicated going forward. So NASA puts up, we have like over 20 satellite missions or instruments flying right now up in space, and many more that are being developed right now that we hope to get up. And the observations you get from aircraft like this, usually we combine the data with this with the satellite data that we have, because usually it's the satellite data that point to something interesting that's going on. And there's not quite enough information that you can get from the satellite data alone to fully understand the question as posed. So then you bring in multiple types of observations from an aircraft like this to go and address those questions.
Okay.
And so what is your background then to be the program scientist?
So the initial experiments I used to do back when I was a postdoc was I put instruments on both high altitude balloons. So these are balloons that go up to 35, 40 kilometers.
Okay.
And we actually flew it a few times on the NASA DC-8. Where we're operating in different viewing geometries. This is a remote sensing instrument. And that instrument operates very much like what some of our satellites do.
Okay.
But it has some things that the satellites can't do, but satellites did things that this instrument couldn't do. But I was the principal investigator for that for a long time, and it was funded by the program that I currently manage.
Okay. Got it.
Oh, you went up that ladder then.
Yeah, I did. Yes.
That's awesome.
Yeah.
Well, that's really cool because you have experience at the levels.
Right.
Yes.
And so now it's not like you understand what all of these scientists and what all they feel.
Yes, I do.
They're kind of their questions and their concerns, and so you're able to help them within the position you're at now.
Yeah. I know what each one of these people do very well.
See, I like that.
Yeah,
that's
I do
awesome.
too. Yeah,
So what was your, all right, you got a PhD in what?
Actually, it was not in earth science. It was in physical chemistry.
Oh my.
But what I learned during my PhD, a lot of the skills applied directly to what I ended up going into my postdoc for in doing earth science. So I was able to take what I learned there, transfer it over. I had a big learning curve to get over, but that's part of what we do.
Yes.
Yeah.
Yes, it is. But that's kind of the fun part of it.
Yeah.
You apply what you've learned to the next thing.
Yeah.
The next thing that you want to investigate.
That's right.
Yeah.
Is we've interviewed so many different scientists and stuff, and the big thing I always ask them is, how do you decide on your question? You know, how do you decide what to research? And it just seems overwhelming to me. There's so many questions out there.
There are a lot of questions out there. Yes, I'm involved in many of them, not just in stratospheric science. I'm involved in questions in many other areas as well.
Okay. Are most of the projects, you said 8 or 9 that you're overlooking right now?
Yeah, it depends on how you define them, because I oversee actually a few hundred grants, but kind of on the larger scale, I'd say 8 or 9 projects.
Major projects?
Yeah.
A few hundred grants.
Yeah.
Holy cow!
I know.
That's a lot of work.
Yeah.
That's a lot of work.
Yeah.
Yes. That's why I'm on telecoms all the time. You
Oh.
see me with earbuds stuck in my ear because I can't stop them while I'm in a place like this, or I'd rather not be doing the telecoms, but
Yeah.
sometimes have no choice.
Yeah.
Well, that totally makes
It's
sense.
part of the responsibility.
So let's say someone was curious about science, maybe a high school student just graduating, and they're like, well, this would be really neat to be in some kind of project where I could further the understanding of mankind. And that sounds like a very grander thing, and yet it's obviously obtainable because people here are doing it.
Yes, that's correct.
Yeah, I mean, you're helping them do it.
Yep.
And so what advice would you give someone like a student that might want to someday be in a position where they can also do the research and then eventually help others do research?
So usually when I meet a young person like going off to college, I tell them there's 2 things you should do in college regardless of what you major in. Exactly 2.
Okay.
They're not easy, but do these 2 things and you're okay. Learn how to think and learn how to write. If you do those 2 things, you won't perfect them in college, you never do. But if you get good at it, then the sky's the limit. So that's what you should do.
I like that.
Yeah.
I like that.
Yeah, I think especially that I have a couple of teenagers now, and I just think that communication piece. If you, I think a solid understanding of content is awesome. But if you can communicate that understanding and help others understand that is so important, and that's a challenge for some people.
Yeah.
Yeah. Now, what about because we have the podcast that we're doing.
Yes.
And so a lot of people listen to our podcast. They're just, your average person interested in science. Because it's pretty cool, let's face it. Even if you don't do it for a living, it's pretty cool. And so what, this might be out there just to stretch, what is the best way, in your opinion, for them to kind of understand or be informed about current type of science that's going on?
Usually people earlier in their career don't necessarily know what the hot topics are, because that really requires getting into the literature, reading science magazine, and sometimes if you pick up those articles, you're not necessarily going to absorb and understand why it's important. So I would recommend them going out and exploring various fields, because sometimes you get involved in a field and it's not for you.
Yeah.
And then you often see people change fields, and then they find another field where they find it much more exciting and much more interesting, and they just kind of need to search it around to find what really works for them, find out where their talents are most appropriate for, etc.
Well, you know what I just heard? They should just listen to Superhero Science and they find out all kinds of stuff.
Yeah. Sounds like an endorsement to me.
Yeah, that's what I just heard. That's what I think I heard. Might just be I thought I heard it. But well, this is awesome. This is awesome. We're very excited, especially because tomorrow is the flight.
Oh yeah.
Yeah.
The flight.
Well,
now, and you've overseen quite a few of these.
Yes.
Any horror stories? Is there times that things just didn't go right?
Oh yeah, they often go wrong. Many times you'll get up and you'll find an instrument's not working, and the scientists involved with that instrument have to scramble. I know, I've been through that myself. So yeah, you have to think fast on your toes. And
Is there ever a failure?
oh yeah, that does happen.
But are we able to overcome the failures?
Often we do. Sometimes the failure is such that you're not going to get the data that you really need for that particular flight, and they can happen on many levels. Sometimes it can be on the aircraft level and not any of the instrument level. Sometimes it's an instrument where, okay, we don't have that particular data for this flight, and you'll still get by with appropriate data. You wish you had that particular instrument's data, but you can still get good data without it.
I mean, you're the NASA program scientist, and so it's kind of the buck stops and starts with you. I mean, if I'm a scientist and it failed, am I nervous about, am I not looking you in the eye for a while?
Nah, I wouldn't worry about that, because we all know what happens on occasion, so that's not a worry. But we always kind of have an idea, if there's an instrument problem that's occurring, is it worth, usually you know beforehand, but not always, but usually. And the question is, do you fly with potential problem with that instrument? And usually make those decisions before you ever go.
Okay.
And we're T-minus a little over 12 hours at this point. It's, what are we, 14, 15 hours away from flight. How much work has each of the teams put in to get to this point?
Oh, years.
Years?
Years.
many of these instruments, they never stop trying to improve the data on them. So yeah, they're always tweaking their instrument, making it work slightly better, putting extra additions on it so like you can see the data more in real time and understand it better. And yeah, they're constantly changing their instruments.
Okay.
You brought up a really interesting thing, and to my knowledge, have they flown one of these? I guess have one of these flights happened with this real time?
Yeah. So all of these flights nowadays, they all get their data back in real time. So they always have to do an assessment of what's the overall data rate going to be, and how do we partition those data rates amongst the various instruments in order to take advantage of seeing what the data are in real time for making decisions on what the plane does next. So that's the way we fly it now.
Okay.
In the old days, we didn't have that. So basically they'd go up and the pilot had basically toggle switches, and that's it. And he'd toggle them on, and the instruments would sometimes, if they had a weird problem, it would basically light an LED in the cockpit to let them know it was a problem. And the only recourse was to reset the instrument. And the instrument scientists had no idea what their data looked like until it got back on the ground, and they took their instruments and downloaded the data off the instruments and started to look at it.
Wow, that'd be stressful.
The very first campaign I was at with one of these things, that's the way it operated.
Yeah.
How long will it take for them? I mean, they're getting it in real time, their data.
Yeah.
So how long before they process or analyze? I mean, how long does this take for a scientific team to do?
It varies per instrument. Most of the instruments, they can have preliminary data fairly quickly, like within a few days or less.
Okay.
Not all of them. But when I say preliminary, sometimes they really want to understand their calibration and other diagnostics to fully vet the data going forward, and that can take months to do that before they come up with their final version of the data. There's one particular instrument on here that's flying in this little, looks like a bomb casing that's underneath. There, what they do is they actually suck in air into cans, and they have like 100 cans in there, and they fill all those cans up during the flight, and then they have to take those back to a laboratory and analyze them. So that or getting those data out take much longer.
What are your expectations for them to do? I mean, you've given them funding, and they've put all this hard work in, they've made these instruments, you've made it happen where they could fly these in the stratosphere and collect their data. What do you, or I should say, what does NASA expect them to do now?
To write papers relative to the questions that they put forward in their proposal.
Okay.
That's what we expect.
And so it basically spreading what they learned to everyone else?
That's correct.
Okay. And that's kind of what it's about.
Yep, that's right.
Awesome. I'm good.
That was very clear.
Okay, good.
Yes, I love that. Thank you very much.
You're welcome.
Thank you so much.
Okay.
Yes, well,
Thank you for listening to this episode of Science from the Experts from Purdue University's Superheroes of Science.
If you like this episode, subscribe, give us a positive review, and share the love. Boiler up!
Hammer down.